For this video, we are going to solve this little bit complicated set of operations. We are to solve for the intersection of two different set complements, but one of which is also a result of another set operation. Included here is the process from here to here. This is all about sets. For this process, we are going to carefully decide which operations should be taken into considerations first. And then we are going to work from there into solving the entire expression. We have three set operations here. We have the intersection, we also have the difference, and the complement of a set. Let's start with this operation first before all other things, because solving for this will allow us to take its complement later on, and we're also going to take the complement of the other set. So let us have the difference of set R and set S. The difference will allow us to remove any element from the first set that is found in the second set. This should be R in the first place. So R is a set containing 2, 4, 6, 8. Take note, this is not yet the final answer. This is just the entire set of R. But we are going to remove S. Removing S means we're going to remove 1, 2, and 3 from this set. 1 is not here, so it would not be removed. 2 is there, so we remove this. 3 is not here, so we have this as our final result. In short, the difference of set R and set S is a set containing 4, 6, and then 8. We'll be using this to get the entire operation here, which is concerned on the complement. So we will have it the complement of the result when we take the difference of R and S. In every complement, which also concerned with the second, we are going to use the items on our universal set. Our universal set contains elements 1, 2, 3, 4, 5, 6, 7, 8. Let us write it here or rewrite it here. So we have here the elements 1, 2, 3, 4, 5, 6, 7, and 8. These are the elements of your universal set. The complement of this result would mean we're going to remove these elements of our universal set, and what remains would be the result. I'm talking about removing 4, 6, and then 8. After that, this is now the expression for the complement of the difference of R and S. It contains the elements 1, 2, 3, 5, and 7. This is now the result for the first group of operations. Before we can take its intersection with this, we need to understand the result of this as well. Take note that the complement of set T will still refer to the universal set. Let me rewrite the universal set here. Again, it contains the elements 1, 2, 3, 4, 5, 6, 7, and 8. And then we just simply remove the elements of set T, and what remains is our T complement, talking about 1 and 4. So our T complement, or the complement of set T, contains the elements 2, 3, 5, 6, 7, and 8. So again, we remove the elements 1 and 4. Now that we have the two complements, we will now look into the intersection. The intersection, let me write it here. So we're going to solve for the intersection of the complement of the difference of set R and set S. We're going to take the complement with the complement of set T. This includes the elements that are found in both complements, because intersection allows us to record the common elements for the concerned sets or result of set operations. So these are the elements of the first set of operations, 1, 2, 3, 5, and 7, and this is for the second. Simply look at the common elements. 2 is here and here, so the first element is 2. 3 is here, 3 is here, so you also have here 3. Then we have 5. We have 5, and then 7. So we have here 7. Notice that 1 for the first group of set operations is not found on the complement of set T. And also elements 6 and 8 are not found to the other. So this is now the complete result for this entire expression. Notice how we started with the specific operations and ended up with this result. Whether or not you're a student who likes math, a student who wishes to understand math, or a student who loves math tasks, you all have something in common. And that commonality could make you as our next subscriber. Subscribe now.